So for our first example, I want to find the multiplicative inverse of 8 mod 35. And to do this, we need to find the Bezout coefficients of 8 and 35. In particular, we're going to start by employing the Euclidean algorithm. So we're going to take 35 and divide by 8. 8 goes into 35 4 times with a remainder of 3. 3 goes into 8 twice with a remainder of 2. And then we're going to bring down, so again, we bring down these numbers. 2 goes into 3 once with remainder 1. And then finally, 1 goes into 2 twice with remainder 0. We don't really need this last line. So once you get to 1, you can stop basically. And then we're going to work backwards to find the Bezout coefficients. So this tells us that 1 we can think of as 3 minus 2. Okay, and then we're done using this equation. Next, we're going to look at this 2. And it turns out that we'll think of 2 as 8 minus 3 times 2. I don't know why my pen turned to purple here. And so this is going to be, really we're thinking of this as, let's see, we have 3 minus 8 plus 2 times 3. So that's 3 times 3 minus 8. Okay. And then we're done with these two, and we'll move on to the next one. Then we're going to replace 3 with 35 minus 8 times 4. I'm just going to replace one of the 3's. This is something that I was hoping would come up in one of the videos that we did. When you have two values, here we have 2 3's, and 3 is the next term that we're going to replace with the GCD. You just replace one of the 3's with what you want. So I'm going to replace the second 3 with 35 minus 8 times 4. And then that's minus 8. Okay, so just replacing this 3 with 35 minus 8 times 4. If you do it with both of them, then things get a little bit muddled. So it's true, of course, if you replace both 3's with 35 minus 8 times 4, what you get is a true statement. It's just not helpful for us anymore. So you just replace one of them. So it turns out that this is 1, that's 3 times 35, minus 12 times 8, minus 8. So in other words, 1 is 3 times 35 minus 13 times 8. And let's just double check. If we take 35 times 3, that's 105. That's 90 plus 15. And if we take 13 times 8, that's going to be 24 plus 80, so 104. So yeah, so 105 minus 104 is 1. So everything is perfect. Now, what we're going to do is remember that we wanted our goal, so we wanted to find 8 inverse mod 35. And so it turns out that in the way I like to do this is I always like to do this just the same time. You might be able to see what's going to happen already, but I like to just write it out, that 3 times 35 minus 13 times 8 is congruent to 1 mod, we're working mod 35. Okay, and so we've seen that. Now, 3 times 35 is really just 0, mod 35, because 35 is 0. So this tells us that negative 13 times 8 is congruent to 1 mod 35. So mod 35. And then from there, what we get is that the multiplicative inverse of 8 mod 35 is congruent to negative 13. And negative 13, if we just add 35 to it, negative 13 is going to be 22 mod 35. Okay, so it turns out that the multiplicative inverse of 8 mod 35 is 22. Let's again double check that. So here what we want to do is we're going to multiply 22 by 8. And this is going to give us, let's see, 16. So we get 16 plus 160, if I can do that right. 16 plus 160, so that's 176. And then let's go back and let's think of 176 in terms of multiples of 35. So we know that We know that 105 is a multiple of 35, so we can subtract 105, and that gives us 71, and then we can subtract 70. So what I'm doing is I'm subtracting multiples of 35 because I know that I can add or subtract any multiple of 35 as much as I like, as many times as I want, and then that'll respect the equivalency class mod 35. So again, you can always just add. It's the same trick that we did over here. We added 35 to this, and that kept the equivalency class the same. And here we're just subtracting multiples of 35 until we get a number between 0 and 34. So that is it. So 8 inverse really is equivalent to 22 mod 35. And then one final step, let's solve 8x is congruent to, say, 10 mod 35. We know that there will be a unique solution because 8 and 35 are relatively prime, and we saw that when when A and M are relatively prime, there's a unique solution. And our unique solution here is going to be found by multiplying both sides by the multiplicative inverse of 8. So what we're going to do is we're going to take, in our case, we did all this work to find that 22 is the multiplicative inverse of 8 mod 35. That's going to be congruent to 22 times 10 mod 35. And therefore, 22 times 8 is just going to be 1 mod 35. We don't really have to check that. We did all this work already. We know that 22 times 8 is 176. That's 1 mod 35, so we've already done that work. This is 220 mod 35. And so now what we have to do is we just have to reduce this to a number between 0 and 34. So that's our goal. And you can do this just by subtracting multiples of 35 as much as you like. Notice that 70 is a multiple of 35. And so it turns out that if we were to subtract this, we would end up with x is congruent to 10 mod 35. And you can check that that's going to be a solution to our system, not to our system, to our congruence up here. And if you take x equals 10, you get 80. 80 is 70 plus 10, so it's a multiple of 35 plus 10, so it's congruent to 10 mod 35. Okay, so this is how all the pieces fit together to be able to solve linear congruences.